This is g3c. In this one, we're going to look at right triangles, but not just any ones. We're going to look at special ones. In particular, we're going to look at triangles that have this combination, right angle 30 degrees, and this angle is 60 degrees. The other triangle that we're going to look at is like this, and this is also right, and it happens to be 45 degrees and 45 degrees. At this point in time, since the base angles are congruent, I'm going to point out that this is also isosceles. So the words up here specifically say, use the properties of special right triangles to, and then here's the key, solve problems. So I'm going to teach you first of all what the shortcuts are with these. If you don't know these shortcuts already, I'm going to teach you real quick. The shorter leg, which is right here, it's opposite the 30-degree angle, is 1. In order to get the length of the longer leg, I just go ahead and I multiply that by the square root of 3. And then, if I want the hypotenuse, I multiply the shorter leg by 2. So in this case, it would be 2. So, if you're given any one of those combinations, you can figure out what the other side lengths are. And this works every single time as long as you have a 30 degree, 60 degree, 90 degree in the triangle. This is our 45, 45, 90 triangle. And in this case, remember, it's isosceles. So these two sides are exactly the same. Let's say that this length is 1 and this length is 1. Every single time, all you have to do is multiply the length of that leg by the square root of 2. So this hypotenuse in this case is 1 times the square root of 2, which is the square root of 2. So let's take a look at a couple of problems. So here we have a 30, 60, 90 triangle. This is a real basic problem. First question, what is the length of the hypotenuse? Well, all you have to do is take the shorter leg and multiply it by 2, and you find out that that length is 32. And then secondly, what is the length of the longer leg? Well, you take the shorter leg and you multiply it by the square root of 3. So the three lengths in this triangle would be 16 for the shorter leg, 16 times the square root of 3 for the longer leg, and 32 for the hypotenuse. Here we have a 45, 45, 90 triangle. The EOC could give you a triangle just like this, and what they really ask is, what is the length of this leg? So you would have to say, oh, well, that's easy because it's isosceles, so the legs are the same. It's 8 and 8. And then the second part to this would be, well, what's the length of the hypotenuse? Well, you simply take the the length of the leg, and you just multiply it by the square root of 2, and that is the length of the hypotenuse. All right, to wrap this up, I'm just going to give you a last example here. I'm going to give you a 30, 60, 90 triangle. There's 30, 60, 90. And I'm going to tell you the hypotenuse right here is 14. So I did this on purpose because you have to know the relationships forwards and backwards. Because the relationship that I showed you before was that you start with this length, the shorter leg, and then you multiply by 2 to get the hypotenuse, and you have to think, well, I'm going backwards, and so that means that you divide by 2, which means that the shorter leg is 7. And then what do you do to that shorter leg to get the length of the longer leg? Well, you take that and you multiply it by the square root of 3. So there you have it. It's 7 root 3 inches long. You know, just a quick note here that, you know, if you get an answer like this right here, that's fine for geometry class. You got to think about what you're going to use this for. You know, if you're looking for the length of a piece of plywood, you wouldn't walk into the hardware store and say, hi, I need it to be 7 root 3 inches long. You would obviously get out a calculator and multiply it out. Alright, so there you have the shortcuts for these special right triangles and a few examples that are great examples for what the end of course assessment is actually going to look like or could look like for this topic.